give us some of the background in the beginning. Why not? This is a big topic, and we have a lot of things happening and revolving around this. We're obviously going to get to the expedition that you guys have planned as a central theme here. But first of all, tell us when and why you got interested in the concept here of the Hollow Earth, Brooks.
That's a good question. Actually, it was, I think in 2001, someone handed me a book about the Hollow Earth, and I read it, and I found it kind of amusing, and I returned it to them, and it just kind of stuck in the back of my mind. I was a traditional scientist. I was educated in the classic way with the traditional geology books that tell us that we live on a molten ball floating through space, and we exist on tectonic plates, much like cornflakes in a bowl of milk. Everybody believes that. The scientific community is comfortable with it, and so I kind of felt that Hollow Earth was just kind of wacky at the time. But over the years, from 2001 to 2005, some pieces of evidence began to fall into place which called into question the traditional way of looking at a planetary core geology, namely the Earth. And some of this data came from space, one of which was a satellite photograph of the Earth that showed active auroras over both poles at the same time. Well, I had always thought that the auroras were caused by the solar wind. So I tried to figure out how the solar wind could be striking both sides of the planet at the same time. And I've seen plenty of animated models of how the ions kind of flow around the planet, and that's what causes them. But evidently, NASA had some questions about it too, because they began to put together two space programs, to try to figure out the origin of the auroras. One was called the Themis program, which was a capsule with 5 satellites in it, which were placed in 5 different levels of orbits so that they could be turned on at the time the solar wind comes in, or at the time that these auroras are activated, so we could find out what the source was. Well, if they were in question about it, then I thought, gee, maybe I'm in question about it. So I went looking for sites that had to do with Hollow Earth theory, and there weren't very many out there at the time, and some of them were way out there. But there was a group putting together an expedition to go above the Arctic Circle to investigate maybe one of the oldest myths of all time, that there's some kind of opening above the Arctic Circle that leads into the inner Earth. Well, I thought, gee, that's really fascinating. Now, that's hard data. I can get into that. So I looked up the team, and it was led by, sure enough, a very bona fide expedition leader, Stephen Curry. He was a very successful expedition leader, and so I found out what it would take to join the expedition, and as it turned out, they were struggling with methods of measuring the curvature of the Earth. And I shot out the regular answers. Well, why don't you just use GPS satellites? And they said, well, we tried that, but above the 60th parallel, you can only see 3 of them from sea level, and that's not enough to get accurate altitude measurements. Mm-hmm. So I said, well, why don't you just use sonar, just bounce it off the sea floor? And they said, well, the sea floor is 4,400 meters deep, and it's quite convoluted with mountains and valleys and everything, and we really can't tell the curvature of the Earth by doing that. So it really presented an interesting scientific problem. And so I proposed that we use a very accurate, precise gyroscope, much like they use in spacecraft. And so I contacted Honeywell, and they did in fact have a gyroscope that could be set somewhere below the Arctic Circle, say in St. Petersburg, Russia, and then kept running while the ship is moving forward, and you can actually track the rate of change based on the forward motion of the ship. And if the rate of change begins to increase, then that indicates you're sailing into some kind of depression or even a lip that might lead into the inner Earth. Because if this opening is 80 or 100 miles across the way the theories say, you'd never be able to tell by ship, because you can only see the horizon about 8 or 9 miles away. So you know, all that would happen is it would cloud over, and you would have no idea that you're sailing into this void in the inside of the planet. And of course, it would take days to get in there. Maybe even 30 days to sail all the way around that horn into the inner Earth. So we decided that we would launch the expedition, and I think this was going to be in the summer of 2007. And so we were making preparations in the summer of 2006, and very suddenly, very tragically, Stephen Curry passed away with a rapid onset brain cancer. So the team did not have a leader at the time, and so they elected me to lead the expedition. Well, that was in 2006. So with Stephen Curry's death, the way the funds had been collected, the right thing to do was to return the funds to everyone who had bought a seat on the ship. And we changed our strategy. Instead of selling seats like a giant tourist program, we decided to make it a more scientific expedition. We would raise investment money, shoot a documentary, and try to recover the investors' money by marketing the documentary and whatever film footage and discoveries we make above the Arctic Circle. And we started putting it together. And it looked like it was going to happen in the summer of 2008, which was reasonable. And we were going along fine. Things were coming together. We had gotten several universities that were interested. Some great papers had been published by Washington University, Harvard, MIT, Stanford. And then we had the worst economy to hit, and I don't know when, maybe since the Great Depression. And the expedition has had a difficult time recovering financially since then, but it looks like it's going to happen in the summer of 2012.
There you go. Interesting year. Maybe timely. Who knows how these things operate? I just wanted to ask you, of course, because some people will I guess, wonder, Stephen Curry, any foul play? Did he just get sick and pass away, do you think, or what happened there?
You know, there are always questions about this. I spoke to Stephen in November. He was fine. We were in Salt Lake City, Utah, where he lives. And all the plans were going forward. We had lots of excitement, lots of momentum. We'd raised a little over $250,000, which was a good start on the expedition. And 5 months later, he was dead. And he didn't have a health problem in the world. This was a healthy, vibrant family man with a great reputation, a great Earth explorer, and a rapid onset brain cancer. I guess that's the way it comes on, but it sure seems strange to us at the time.
Yeah. Okay, well, we're going to get into, obviously, the nature of the expedition, how things has evolved since the time you began planning it back in, basically, to go back in 2006 there then, and now it's been a few years since then. I just wanted to ask you about some of the other aspects here first, in terms of what you think about how planets form, and just try to give people some of the idea about the planetary theory of how actually they are formed. When you mentioned that you've seen images of auroras on both poles at the same time, I remember seeing the same on Saturn, for instance, when the Cassini mission went by. So this means that it's probably happening on several planets, meaning Earth in that regard isn't anything special. What do you think, Brooks?
Well, it's very interesting. You know, I guess the first mainstream scientist to think about stuff like this was Edmund Halley in 1629. It goes back a long way, and he was well respected. Obviously, discovered Halley's comet and predicted its return, and it returned almost exactly as he predicted, and is since named after him. Of course, we don't have the comet anymore, but we do have the tail that comes around every year. Now, since then, you know, many scientists have looked at it, and most people are familiar with Sir Isaac Newton, who was a great thinker, and his planetary movement theories have been vindicated over the decades by the greatest physicists in our time. He had two sets of theories for how planets form. One was called thin shell physics, where he calculated the mathematics inside and outside of a sphere. And he calculated that inside a thin crusted sphere, there would be zero gravity, because the gravity would center in the crust of that sphere, and it would be because of the square of the distance and the distance you are away from the other side and close proximity to this side, all the gravity cancels out on the inside. Mathematically, it makes a lot of sense. And then he developed thick crust physics. And it was just an extrapolation of the thin crust physics, but there was never any empirical data to back it up. Everybody just accepted it because he was so successful with his planetary movement theories that no one gave it a second thought. But when I started applying, I would call it Einsteinian philosophy. You know, Einstein liked to put people in elevators and theoretically and do his theoretical physics so that people could understand it. So I put it like this. Let's suppose that you and I were in an elevator and you were standing on a bathroom scale at your location, and that elevator shaft went all the way to the center of the earth. So we hit the down button and we watch your weight on the scale. What would you suppose that your weight would do when we arrived at the exact center of the planet?
I have no idea. I mean, wouldn't it be, if we go with the conventional theory, for some reason I have an idea that it would be heavier, or would be much heavier, right?
Yeah, I would think so, because you kind of assume the mass of the body around you. That's why you're thrown around much more violently in a Cadillac than you are a Volkswagen when you turn corners. However, according to Newton, as you neared the center of the planet, your weight would become less and less and less, until, in our Einsteinian elevator here, we reach the exact center, and lo and behold, we look down and your weight is zero. Because everywhere you look is up, everywhere you look is toward the mass of the planet. So if that's true, and Newton is correct that the more mass you collect, the more gravity a body develops, then gravity centers in the crust of the planet, not in the core of the planet.
That's right.
And actually, planets would tend to form as hollow spheres and not as solid balls.
Interesting. So what do we think is down there then, in that sense? Are we talking about things like the inner sun and a huge opening cavity, or is it more like formations, if you will, of a Swiss cheese, and the deeper into it we get, the more cavities we get? What do you think?
Well, I think both of those are good theories. Let's talk about maybe how planets form. Let's just assume that cosmologists are correct, and that galaxies form out of a giant swirling ball of gas, and over billions of years, various eddies form in this swirling mass, and little solar systems and little stars and little planets begin to form just because dust and ice is coagulating in various orbits around this newly forming galaxy. If that's the case, then obeying the law of what we call the conservation of momentum, which is really a combination of the first and second laws of thermodynamics, think of it like an ice skater. She goes into a spin, and as she draws her arms and legs into a tighter and tighter radius, she spins faster and faster and faster.
Right.
This is conservation of momentum. Now, planets do this, stars do this, black holes do this, and galaxies do this. Well, planets assume one of three different conditions. A, they spin so fast that they explode. B, they become lopsided and they sort of throw off a piece of themselves, forming a moon, which is, we have evidence of that in our own solar system. Mercury was once a moon of Venus, and so, Venus spit off a piece of itself and formed Mercury, and then Mercury was heavy enough that it broke away and formed its own orbit around the sun. The third condition is that they spin and they expand and cool and expand and cool. And of course, as they do, they begin to slow down. This is sort of let's call it the Goldilocks zone of forming planets. They don't fly to pieces and they don't get lopsided and throw off a piece of themselves, but they are just perfectly homogeneous in the way that they form and the way that they begin to cool. Now, this brings into light a theory called expanding crust theory. And it doesn't take but a 9-year-old to look at the Earth or a picture of the Earth from space to see that all the continents do fit together quite nicely, or at least the continental shelves do. And for a long time we had the theory called Pangea or Gondwana land, where all the continents were together on one side of the Earth and the rest of the planet was water. However, the continents fit together on both sides. So Gondwana land and Pangea have long since been rejected as a viable theory of plate tectonics. Instead, this theory called expanding crust theory begins to take shape, which is that Earth, if you shrink it to 1/3 its present diameter, all the continents fit together perfectly on both sides, including Australia, New Zealand, Antarctica. Everything fits, and allowing for erosion, a little bit of loss due to active volcanoes. Everything fits together perfectly. And according to Occam's razor, if you start slicing away at all the evidence, you realize that as fantastic as it is, it makes a lot of sense. Now, if that were the case, we would find two pieces of empirical evidence left behind this whole process. First of all, we would find oceanic deposits like sediments high up in the mountains, layers of fossils and seashells and things like that. And guess what? That's what we find.
Yeah.
We find it in the Himalayas, we find it in the Rockies, we find it in the Appalachians. Some of the oldest mountain formations on the planet certainly do have layers of sea life fossilized as though they settled to some sort of sea floor. The other thing that we would find as empirical evidence is that the sea floors would have to be radically different in geologic age from dry land. And that's exactly what we find. The oldest sea floor sampled on this planet is only 70 million years old. Dry land is 4.5 billion years old. So it does tend to support the idea that the crust has been expanding for tens of millions of years. And at doing so, of course, the diameter gets larger and larger, dry land appears, and the seas drop down into the cracks formed by the crust coming apart and cooling. And that's pretty much what we see, and it's still doing it today.
That's right. So according to that theory, and by the way, obviously there are some really good videos on YouTube by Neil Adams that shows the growing Earth, basically, and it's really interesting to see this because it really fits together. And but that would mean then, obviously, that the Earth didn't maybe start out hollow. This is something that happens during this process as the planet grows and expands, and then eventually you get an opening, a cavity inside, correct?
Yeah. At one time, maybe this planet was completely covered by water, with maybe a few very high mountains sticking up out of it like islands. And then as the crust expanded, the ocean settled down into what we call the oceans. And Neil Adams does a fantastic job, and it's animated. But if you look at the way he moves the tectonic plates around, it's beautiful. It's a work. It's not a work of art. It's a work of science. And right. He talks about this evidence in his video, and I have used his presentation in discussions and lectures that I've given because he does it better than anyone. Well, then that means that planets have two different conditions if they reach this sort of Goldilocks zone. One is that there's no core at all, that it's just a big hollow sphere with, 1,000 or 1,500 mile thick crust that's undulating and responding to various tidal gravities and undergoing all its volcanic and magma movements that, like our planet does. The other is that it would break away from a more solid, dense crust or core, and the crust would then, as it expands like the ice skater letting her arms out, begins to slow down. It has a differential in speed between the original core, which might be something like our Earth has, a very solid, almost single molecule iron crystal that's very dense, probably greater than 12 grams per cubic centimeter, an open gap, and then this very thick, dense crust. But the crust is moving slower than the core. And so this counter-rotation, like a giant metal motor or generator, makes this immensely powerful magnetic field around the planet. We call it a magnetosphere. Earth has one. Mars does not. Moon does not. Several planets do not. Most planets do.
This would put the aspect of gravity then in a different kind of interpretation as well. And I've even heard that someone attributed the force of gravity, the effect, if you will, actually, of gravity, to be due to the expanding Earth, in that sense, that through the spin and the expansion of the planet. Now, I don't know if that would be quick enough to produce this process, but basically how this works then, or what we're getting to, is that if you were to sail into the opening of the hollow Earth, and if you didn't have a way of measuring it, like you mentioned before, with a gyroscope or some other technology, you basically wouldn't notice that you're going into the Earth, in that sense, right? So,
yeah, except theoretically, you would just find an uninhabited land with no horizon. You would just sail forever, and maybe like the ancients thought, you sail off the edge of the earth, and we didn't realize that the planet was round. But there is one more piece of evidence, and this is sort of attributed to Newton, but also another mathematician whose name is Lagrange. Lagrange had a theory that there's a point of equidistance, gravitationally speaking, between things like the sun and the earth, and that at least two places in Earth's orbit there's a nice comfort zone where things are neither accelerating nor decelerating away from the earth, and these are called the Lagrange points. It's a point of equidistance between two gravitational bodies. The Lagrange point normally, theoretically, should go from the center of one gravitational body to the center of another gravitational body, except that the Lagrange point for Earth is about 1,200 kilometers short. The center of gravity is not in the center of the planet.
Interesting. So we have a lot of interesting aspects to this, and evidence that are obviously standing up against the normal version of what we get through science, and this is obviously so often the case. But there are some other aspects I want to ask you about as well here, Brooks, which has to do with, basically we could break it down, I guess, if you want to, into mythology, then the history, and also actually recent expeditions, if you will, that has been going both to the Arctic and Antarctic as well. And I want to bring up some examples from that as well, and see what your take is on that. But what about the mythological aspect to this? We hear stories coming to us, obviously, from the ancient past about the inner earth, about the fact that there was another type of beings there. It's in the Vedas or the Puranas. It comes to us from Tibetan, in some cases, traditions about Shambhala and things like that. What do you make of the mythology aspect here?
Well, that's one of the more fascinating versions, or at least aspects to this study, is that modern scientists, we think we're so smart, and all the ancients were so primitive, but they had a pretty good understanding that there was some sort of life force that came out of the center of the earth. Certainly the Toltecs and the Olmecs and Zapotecs believed that life force or life energy comes out of the inner earth. They often spent, most of their leaders had caves, deep caves, that they would go into the earth to try to get closer to the God of creation. The whole idea of the Popol Vuh, which is the ancient Mayan Bible, so to speak, talks about the creation of life coming up out of the center of the earth. The Tibetans use mandalas and various mathematical diagrams to show the relation between the life force on the surface and the life force coming from within the planet, as though the planet were a living being. And it even extends into Tibetan Buddhism and all their symbolism. You go to Egypt and you see that they arranged these almost stellar arrangements of ancient buildings, and most people believe that the pyramids were built a long time before Egypt was Egypt, but they managed to do it in the absolute center of landmass of the planet, as though they understood the geological and spatial dimensions of the planet. And in Abydos, which is not one of the oldest temples, but it's certainly one of the more famous ones in Egypt, there was a very gifted translator and worker there who came from England. Her name was Dorothy Eddy. She had a couple of books written about her by Hani El-Zaini, who I met in Cairo. And she made some handwritten translations of hieroglyphs that were there at Abydos. And I read some of these translations, and I held in my hands her handwritten transcript of those hieroglyphs. And in those hieroglyphs, it mentions that the people once escaped into the earth, as though there was some kind of haven there from some cataclysm, either cosmological or surface oriented, like, say, a giant flood, which most traditions talk about, or a volcano, or some kind of a cosmological body coming in and wreaking havoc on the surface of the planet, and they needed somewhere to go to be safe. Then we also have Hopi legends. These are American Indians that talk about great beings and wise beings that come up out of the inner earth to teach and to care for the people on the surface.
That's right. The ant people, right? That's a common theme that they've had for a long time. And as kind of protectors during times of great upheaval, and obviously we can get into a little bit later what this actually means, if this is... some people have argued that these are the ancient gods. In some way they're caretakers of the human experiment, and we can ask you about that as well. What do you make of it? Do you think that they're really... these stories are really true? There's another civilization even down there? What do you think?
Well, this is kind of the Indiana Jones aspect of this whole expedition. I'm a scientist, and so I don't really believe or disbelieve in anything, but I'm pretty good at putting together a hypothesis and then the experiments to prove or disprove that hypothesis. And this experiment, really requires physical travel to these areas on the planet. I really searched for a long time, both written material and then as the internet became more and more prolific and ancient libraries began to be accessible by the internet. But as it turns out, there's absolutely no data. Now, there are some stories, there are myths, there are first-hand accounts, which over the decades can get even more and more wild and
That's right.
and fanciful. I'll say that. But there's no data. The closest that we've come is one of my ancestors is Sir James Ross of the Ross clan. I'm of the Agnew clan in Scotland, which is 60 miles away in central Scotland. And Sir James Ross felt compelled to look for the North Magnetic Pole. He nearly killed him in early 1800, and then he tried again in 1831, and he was successful. So in doing so, he found a very strange little seagull, which he called the Ross gull. And ornithologists the world over, and I've spoken to the world's experts on this little bird, all agree that this little bird flies north in the wintertime. It's not built for north. It's not a penguin. This is a dainty little seagull, barely a pound or less in size. And yet it flies north and nests somewhere where it's warm. And no ornithologist has ever been able to follow this bird in the wintertime because the conditions are just forbidding. And we've not been able to track it because there are no satellites above the pole that can pick up a transponder of this little bird. It's been tried many times, and it just is never successful. This bird goes somewhere where the satellites can't track it in the wintertime. So there's hard evidence that seems to prove that there's some form of life on the inside of the planet. Now, I will tell you as a scientist, and I have a degree in biology as well as chemistry, I will tell you that if there is a void inside the Earth, there most definitely will be life. Now, it might be microbial, it might be more complex like fish or birds, and it may even be intelligent. It's just difficult to say. The only way to prove it, one way or the other, is to sail to the opening and see if we can film it or call it out or make some kind of live, camera debut of this area for the world to see.
Wouldn't that be interesting? By the way, as I was reading a little bit about James Clark Ross, it was interesting, I think, that one of his ships, he called it the Erebus, alluding to the underworld, basically. Some of these expeditions that have been going to the Arctic and the Antarctic have had some interesting name, but what do you think about, why did they call it the Erebus, do you think? One of them, anyway.
I think it's fascinating because, the drive that takes a man in his early 20s and his passion was unstoppable, which, we Scots can be that way, hard-headed they call us, but it's not, it's passion. And somehow he raised the investment and got a ship and got a crew. And, as I told you, he nearly lost his life the first time he got up there, and the ice began forming so fast he couldn't sail out of it. And it ended up crushing his ship. And what they did is they just took the supplies and hauled it out onto the ice and survived through the winter until a rescue ship could come in the spring. And that's exactly how he made it. Now, he lost a lot of his crew. But then, crazy as it sounds, he did it again. And he was successful that time. The drive that pushes these men out of their comfort zone into the unknown like that when you analyze their writings and you look at the art, you look at the symbolism that drives them, it is it aligns with some of this ancient mythology. Some of it is Greek and Roman, some of it is Nordic, some of it is Indian. It's quite fascinating to see that alignment with inner Earth mythology.
Oh yeah, definitely. And I want to ask you about stories like the Smoky God coming from Olof Jansson. We have a little bit later we had Fritjof Nansen's the Fram expedition. A lot of Norwegians have been up there, obviously. What do you make of some of these? And later we could touch upon Admiral Byrd, of course. That's a big one as well.
Yeah, I read The Smoky God, and I read, Edda Dorfa and some other books written on it. And I've been to Mammoth Cave, and I've been to the deepest points of Mammoth Cave, and I've interviewed the staff there. The deepest point of Mammoth Cave only goes down to 360 feet. Even if it went to 3,600 feet, it would not be far enough to make a dent in what we would call the Hollow Earth. I found Olaf Jansson's book to be the most credible story. The fact that they sailed into an Arctic opening, survived there for a period of time. He and his father came out the Antarctic opening. The ship was crushed. He ended up scrambling out on the ice and being rescued. And the ship that picked him up, as the story goes in the book, said, "How in the world did you get here? Why don't you have provisions for, longer lasting? You're not even dressed for this weather." And when he eventually told his story, evidently in Southern California, or in some place he was interned in an insane asylum for a while until he proved that he was harmless, and then came out and told his story.
Yeah.
But I found the story fascinating. I don't find any flaws in it. It does make sense that if the core is this iron crystal, which the Japanese, by the way, have measured and have confirmed, that not only is it a solid iron crystal, very dense, the tightness of the resonant frequency of this crystal indicates that it's almost pure iron. It's almost perfectly shaped and flawless. And it is probably at somewhere between 5 and 20,000 degrees Fahrenheit, which means that it's glowing either white hot or very bright red, which would mean in an atmosphere of 800 or 900 miles of air, not a vacuum, but air, it would appear as a twilight sun or a smoky god.
Very interesting. So that would be, if we again go back to for a moment to the auroras. Is this where you think that this effect that we're seeing in the sky is coming from the inner sun, if we can call it that?
That's a really interesting question, and I really looked for a lot of data on that, because it's evident that there is an electrojet. There's an ion stream that comes out of the planet from the north and the south poles. You would expect that this would be fairly constant, kind of all the time, like the flux lines would be around the planet, but it's not. It comes and it goes. That's the primary reason for NASA launching the Themis probes in the first place. Now, when they published their paper, it was after one measurement, where all 5 satellites were lined up kind of like a string of pearls headed out into space. In between satellites 3 and 4, there was what they call a cosmic bullet, an interdimensional explosion, they called it. And, of course, the explosion went out 360 degrees in all directions. It passed satellites 4 and 5 and headed out to space, and passed satellites 3, 2, and 1 and headed toward Earth. And when it hit Earth, there was the aurora. So they published the paper and said, "We know what causes the auroras. It's caused from cosmic bullets." I wrote the author and I said, "How can you publish such rubbish? One measurement and you conclude what causes the auroras. You need to have multiple data points, and you need to plot them, not only against the solar wind, but also against the ion streams that come out of the center of the Earth." Of course, I never heard back from them, but that was just bad science.
Well, see, their mind is probably already made up, so if they get one confirmation that would fit within the parameters that they've set, then that would be it. They wouldn't have maybe even the consciousness to actually continue the studies further, right?
Well, you raise an interesting word, consciousness. When I first started in science way back in the early 70s and started applying it in the late 80s, we didn't use words like consciousness. We used, scintillation, or we used, statistics, and we collected data and we plotted it and treated it and tried to make predictions based on that data and make other hypotheses. But we didn't use the word consciousness. Now, some of my colleagues like Amit Goswami and Michio Kaku and others are using the word consciousness mixed in with theoretical physics. In fact, Amit Goswami has a book called, I think it's called The Quantum Activist. And he and I have had some long conversations about this. Sir Roger Penrose, another great scientist, so great that he was knighted. We all look up to him. We read his stuff. His theories are very solid. But he made a quotation one time that I refuted publicly. And he said that consciousness is the result of quantum gravity. And I disagreed. And I published my own version that quantum gravity is the result of consciousness.
Yeah, the reverse of that. Well, we don't know. What is the cause? What is the effect? It could be argued ad infinitum, I guess. But I guess I'm with you on that sense. I think that our consciousness or the consciousness, depending on how we view it, is at the root of most things. And I've heard as well, by the way, Brooks, and I want to get your take on this, that even actually the polar opening functions in this manner, in this way, that there is a barrier having to do, maybe not by belief, but if you are in the right, I don't know how to put it, frame of mind to see it, to get access to it. Do you know what I mean?
Yeah, I do know what you mean, and of course I've tried to put some scientific terms to this that aren't so, Indiana Jones, that you have to, know the right incantation or so to speak, hold your mouth right, or do the right dance, or sing the right song. But there is some truth to the idea that at the end of the day, we are a conscious being existing inside of what I call a biological transducer. We have a nice chemical factory, a spectrometer in our nose and our mouth, and we can determine minute changes in chemical composition. We have eyes, and we can see a very narrow range of radiation between, somewhere around 340 nanometers all the way up to about 900 nanometers in wavelength. We have ears that can hear certain vibrations as they travel across the air. But other than that, we're pretty much blind to the universe. And the universe has lots and lots of information that it's transferring around that we cannot sense without elaborate instrumentation.
Yeah.
That being said, the conscious being inside the human body does seem to have access to these higher frequencies. We not only can receive them, but we can generate them. And there is centuries, millennia of information confirming that civilizations, communities, families, and individuals live longer, live happier, healthier, and stick around to evolve if they have, I'm not going to say a positive attitude, let's just call it a higher vibrational frequency. And individuals, communities, nations, civilizations that have dark or lower vibrational frequencies tend to go extinct. At the end of the day, and I talk about this in my latest book called Remembering the Future, The Physics of the Soul and Time Travel, that the idea that reality is an average of the consciousness of every sentient being in the universe is a mathematical truism. Now, with very large populations, we should have an average that doesn't change very much. That's what we see when we view statistics. The larger the population, the more reliable the average is. You're going to have some corner conditions, but generally it's a bell curve, and right in the middle is where the average consciousness lies. However, that theory is solely based on the idea of static members of that population. we are not static members of the population. We are dynamic members of the population. And our consciousness can change, not only over time in a single lifetime, but over generations our consciousness can change. And if that happens, the input that we put into the universe changes the average reality of the universe, which means we're involved in a very minute way in the creation process itself. So the idea that a gate or a gateway or a dimension or a portal can remain closed or suddenly open depending upon the energy that the being or beings are putting out at the time makes perfect sense.
Yeah, it's an interesting theory, and that would explain quite a bit, and also potentially why some expeditions hasn't seemed to yield anything, while others certainly have, that haven't even been intended for that purpose, but nonetheless they kind of stumble into it, if you will. But before we take a break and carry on here in our next segment, I do want to spend the last few 8-10 minutes or so to obviously to introduce this topic to our listeners here about the North Pole and Inner Earth expeditions that you're behind. Obviously the website primarily for this is npiee.org, where people can go and read more, and it seems to me that you have things pretty much sketched up at this point. You have a couple of potential ships. You're looking at 2012 to go. Tell us about how things are going and what basically what the expedition is about, Brooks.
Well, they're going pretty well. We have 100 berths or spaces on these two ships. They're both nuclear-powered Russian icebreakers, former Soviet military ships. They are the only two civilian ships on Earth that can make this expedition. Now, I'm not saying other icebreakers couldn't go there, but there are two things that preclude any other ship from participating. Number one, these are Russian international waters, so they're not going to let just anybody sail up there. And number two, we're going to be breaking ice for 8 days solid on this expedition. These are the only two ships with ice-rated hulls and a fuel supply, obviously a 3.5-year fuel supply, that can make it there and then stay for a week and then return. So that's why these two ships were chosen. Now, that being said, we have 100 spaces. The original plan was to, we'll simply sell 100 spaces for $20,000 or $25,000 a piece, and we'll go on this marvelous cruise. Well, a cruise it would have been. And just like every expedition, twice a year they go to the North Pole, you'd have a lot of home movies, you'd have a lot of snapshots, and some interesting stories. But they're tourists, they're not explorers, they're not experts, they don't know what they're seeing. We decided that these 100 people had to be very special people. And so we brought Jill Heinerth, who is an under-ice diver and photographer. She's done over 50 such launches for National Geographic. A marvelous asset and explorer to have on this vessel. Elizabeth Williams with Stanford University. She's a PhD and a professor in Arctic plate tectonics. Dr. Sessions, whose graduate student team was the first to analyze more than 600 seismograms put together by the U.S. Geological Survey and discovered the ocean underneath the Atlantic Ocean using these seismograms. This is the team that we've put together to take these 100 spaces. World-class film and filmmakers, not only in visible light, but in infrared light. So we can film in multiple wavelengths and thus be able to see things the naked eye can't see. And, of course, some managers, some historians, some people that are experts in sea chemistry, oceanography, Earth anomalous magnetic fields and atmospheric conditions, so that we can actually measure and bring back hard data to say this region of the Earth is different than any other region on the Earth. So now we've got a team, and by the way, we had almost 3,000 applicants for those 100 spaces. We have a film crew. We have a marketing plan for taking the almost 5,000 or 6,000 hours of film, and I don't know how many digital photographs will be taken above and below the ice. But now what we're doing is we're looking for the funding to be able to take this off. And we have several investors that are interested. So that portion of it's being put together. We have the corporate structure put together. It's a nonprofit. We don't seek to make any money on this. I've put almost $40,000 of my own money and 6 years of my time putting this together. So it's a passion. We work on it every single week. We do something on it. So it is coming together, and radio programs like yours give us the exposure to the public to further the interest. I would say now more people know about the Hollow Earth since our film in 2007. We won the Genes of Galileo contest in Japan with it, than knew about Middle Earth before the movies came out.
Mm-hmm. Interesting. But so at this stage, you're not looking for people to get aboard, literally, so to speak, and buy a ticket to the cruise, correct?
That's correct. We're not looking for paid tourists. Lots of people have offered us money for a seat, and some of those people are going to come because they do have the skill sets we're looking for, but we're not accepting their money. That's not the mission to sell seats on the ship. Many of the scientists, most of the scientists, do not have the money to take a cruise like this, and it's not going to be that easy. We also had to vet people based on physical stamina, their ability to withstand seasickness, because we're going to be in the roughest oceans on the planet. Some of it's 10-story seas, 70-mile-an-hour winds. Temperatures can range from 38 above to 20 below in a moment's notice. So this is not going to be a pleasure cruise by any stretch of the imagination. It might make the ultimate reality film. I don't know.
Is that what you're planning to do with the camera cruise there as well, or how are we going to structure that?
Well, we have 3 different crews. One is going to be filming a kind of reality in that those cameras are going to be going 24 hours a day all the way through the cruise, and they will be on multiple channels online. So anybody that wants to log on can key into that camera and can watch what that camera sees. And some of it will be watching the scientist work. Some of it will be outside the ship looking at the horizon. Some of it will be interviews that we do with the 100 people and the 150 crew members, how they feel, what's going on, what kind of training's happening, how are you affected by this cruise and being isolated, knowing there's no rescue ship behind us. We have to go in and come out like we're going to Mars and back. And that's just going to be interesting to watch. The other will be a crew putting together a 13-piece miniseries for the cable channels, and the other will be putting together a higher resolution film and some scripted things for a feature film.
Well, there you go. So a lot of things happening there, obviously. What time of year, by the way, are you planning to go?
We're going to go after the 4 regular Arctic cruises are done with these ships. So that will be in August of 2012. We're right up against it because the ice begins to reform in early September. And by the time we get into October, the ice is forming at the rate of about 10,000 square miles a day. So it's very difficult to get out of there. The reason we want to go in August as opposed to right in the middle of summer, like say June during the summer solstice, is because we would really like to have some partial sundown event. In June,
right,
as you know, the sun's above the horizon 24 hours a day, but in August it does go down over the horizon. We want to be able to see the stars, some of the auroras if that's possible, and get some non-sunlight measurements.
Because there could be, if it's true what you mentioned before in terms of the nature of the inner light, if you will, there could actually be a region where you could see some of this light coming through, basically.
Yeah, and I have to say, with part of the hypothesis, part of the theory is maybe there's intelligent life down there, or maybe there's intelligent life on the sea floor, which, quite frankly, if I was from another world and I wanted to stay unbothered for a few millennia, that's where I'd put my ships. But
right.
The idea is that we can put a consciousness signal, a 450-foot-long, 23,000-ton vessel, in the middle of nowhere, literally hundreds of miles from the next human consciousness, and that we could be such a positive, shall I say, higher vibrational beacon that even though we can't sail this nuclear-powered vessel inside the Earth, it's an impossibility.
Why? Why?
Well, for one thing, the shipping company that owns the ship doesn't want to sail it in there. It's too risky. They may not be able to get out.
But sorry to interrupt, but is this the idea? Have you been in communication with them and said the idea, and they said, well, that sounds cool, but no, we can't do that? Or what was the response there?
Yeah, pretty much. They said the first time up, if we do find an opening, we just as soon park some distance away. We'll use the helicopter. We'll use the other smaller boat that's on the ship to make excursions. And I said, that's probably a really great idea. You know, it's nice to get 250 people out and have less than one death. I think that's the plan. However, if we create this sort of consciousness beacon, this higher vibrational presence, maybe the gateway will open and they will come to us. And if they come up out of or off the bottom of the sea or out of this opening, and we get it on film, live on the internet and on film for posterity, everything changes, don't you think?
I would think so. How interesting. Obviously, Brooks, we have much more to discuss, and I want to take a short little break at this point and then carry on here in the next segment. And obviously I want to ask you about potential people who might be having, already an awareness of this and want to try to prevent you from this, but we'll get into it a little bit later. Why don't we wrap things up then there for this first hour, talking about your website. You mentioned, of course, as well, your book, Remembering the Future. We mentioned the website, npiee.org, the North Pole and Inner Earth Expeditions. Then you have some other stuff out there as well. Go ahead and mention that to us, Brooks, so people know where to get a hold of you and look more at your info.
Yes, in 2004, my co-author and I wrote the first of a series of books called The Ark of Millions of Years, like Noah's Ark. That's anciently what the Zohar says he called his ship. So we wrote 2,000 pages over 4 books, which were published from 2004 to 2009. And they have been on the Amazon bestseller list 6 times. So now that we're nearing 2012, if you are curious as to what it means, where it came from, who started it, what ancient civilizations have ideas about this rendezvous with Earth, with the rift in the Milky Way, there's no finer collection on the planet, according to Forward Magazine, and I would encourage you to go to arkofmillionsofyears.com and pick up a set for yourself. By the way, the first 2 volumes are free in audio if you order either Volume 3 or the trilogy.
Excellent. There you go, arkofmillionsofyears.com. You also have, obviously, Brooks, x2radio.com as well. You do your own radio program, so people can tune in to you there, obviously, as well. Anything else now you want to mention before we take a little break here, then?
Just that Remembering the Future, the Physics of the Soul and Time Travel is at rememberingthefuturebook.com, and if you buy the paperback, you'll get the audio version for free. So if you're not a good reader, don't worry about it.
Well,
I read it for you.
Yeah, well, that's excellent. I think many people have the a wish to have it in their, iPad or iPhone, whatever they use these days, MP3 players, because it's quite busy, a lot of things to listen to. So that's a great idea. Again, then remembering the 100
miles across the way the theories say, you'd never be able to tell by ship because you can only see the horizon about 8 or 9 miles away. So you know, all that would happen is it would cloud over, and you would have no idea that you're sailing into this void in the inside of the planet. And of course, it would take days to get in there, maybe even 30 days to sail all the way around that horn into the inner Earth. So we decided that we would launch the expedition, and I think this was going to be in the summer of 2007. And so we were making preparations in the summer of 2006, and very suddenly, very tragically, Stephen Curry passed away with a rapid onset brain cancer. So the team did not have a leader at the time, and so they elected me to lead the expedition. Well, that was in 2006. So with Stephen Curry's death, the way the funds had been collected, the right thing to do was to return the funds to everyone who had bought a seat on the ship. And we changed our strategy. Instead of selling seats like a giant tourist program, we decided to make it a more scientific expedition. We would raise investment money, shoot a documentary, and try to recover the investors' money by marketing the documentary and whatever film footage and discoveries we make above the Arctic Circle.
Give us some of the background in the beginning, why not? This is a big topic, and we have a lot of things happening and revolving around this. We're obviously going to get to the expedition that you guys have planned as a central theme here. But first of all, tell us when and why you got interested in the concept here of the Hollow Earth, Brooks.
That's a good question. Actually, it was, I think in 2001, someone handed me a book about the Hollow Earth, and I read it, and I found it kind of amusing, and I returned it to them, and it just kind of stuck in the back of my mind. I was a traditional scientist. I was educated in the classic way with the traditional geology books that tell us that we live on a molten ball floating through space, and we exist on tectonic plates, much like cornflakes in a bowl of milk. Everybody believes that. The scientific community is comfortable with it, and so I kind of felt that Hollow Earth was just kind of wacky at the time. But over the years, from 2001 to 2005, some pieces of evidence began to fall into place which called into question the traditional way of looking at a planetary core geology, namely the Earth. And some of this data came from space, one of which was a satellite photograph of the Earth that showed active auroras over both poles at the same time. Well, I had always, expedition leader Stephen Curry, he was a very successful expedition leader, and so I found out what it would take to join the expedition, and as it turned out, they were struggling with methods of measuring the curvature of the Earth. And I shot out the regular answers. Well, why don't you just use GPS satellites? And they said, well, we tried that, but above the 60th parallel, you can only see 3 of them from sea level, and that's not enough to get accurate altitude measurements. Mm-hmm. So I said, well, why don't you just use sonar? Just bounce it off the sea floor. And they said, well, the sea floor is 4,400 meters deep, and it's quite convoluted with mountains and valleys and everything, and we really can't tell the curvature of the Earth by doing that. So it really presented an interesting scientific problem. And so I proposed that we use a very accurate, precise gyroscope, much like they use in spacecraft. And so I contacted Honeywell, and they did in fact have a gyroscope that could be set somewhere below the Arctic Circle, say in St. Petersburg, Russia, and then kept running while the ship is moving forward, and you can actually track the rate of change based on the forward motion of the ship. And if the rate of change begins to increase, then that indicates you're sailing into some kind of depression or even a lip that might lead into the inner Earth. Because if this opening is 80 or 100, and we started putting it together, and it looked like it was going to happen in the summer of 2008, which was reasonable. And we were going along fine. Things were coming together. We had gotten several universities that were interested. Some great papers had been published by Washington University, Harvard, MIT, Stanford. And then we had the worst economy to hit, and I don't know when, maybe since the Great Depression. And the expedition has had a difficult time recovering financially since then, but it looks like it's going to happen in the summer of 2012.
There you go. Interesting year. Maybe timely. Who knows how these things operate? I just wanted to ask you, of course, because some people will I guess, wonder, Stephen Curry, any foul play? Did he just get sick and pass away, do you think, or what happened there?
You know, there are always questions about this. I spoke to Stephen in November. He was fine. We were in Salt Lake City, Utah, where he lives, and all the plans were going forward. We had lots of excitement, lots of momentum. We'd raised a little over $250,000, which was a good start on the expedition. And 5 months later, he was dead. And he didn't have a health problem in the world. This was a healthy, vibrant family man with a great reputation, a great Earth explorer, and a rapid onset brain cancer. I guess that's the way it comes on. But it sure seems strange to us at this thought that the auroras were caused by the solar wind. So I tried to figure out how the solar wind could be striking both sides of the planet at the same time. And I've seen plenty of animated models of how the ions kind of flow around the planet, and that's what causes them. But evidently, NASA had some questions about it too, because they began to put together two space programs, to try to figure out the origin of the auroras. One was called the Themis program, which was a capsule with 5 satellites in it, which were placed in 5 different levels of orbits so that they could be turned on at the time the solar wind comes in, or at the time that these auroras are activated, so we could find out what the source was. Well, if they were in question about it, then I thought, gee, maybe I'm in question about it. So I went looking for sites that had to do with hollow earth theory, and there weren't very many out there at the time, and some of them were way out there. But there was a group putting together an expedition to go above the Arctic Circle to investigate maybe one of the oldest myths of all time, that there's some kind of opening above the Arctic Circle that leads into the inner Earth. Well, I thought, gee, that's really fascinating. Now, that's hard data. I can get into that. So I looked up the team, and it was led by, sure enough, a very bona fide